So integration with limits. So this is our session's main topic. But before going to this, I want to discuss something which is very important that can come in the entrance. Yeah. I think you can all see this particular formula. E power x f of x plus f dash of x to dx e power x f of x. Okay. So f of x is nothing but a function. Correct? F dash of x, we all know what it is. For example, if it is x square, what is f dash of x? 2x. So there is nothing but differentiation. So this common question is seen in the entrance examination. Okay. So e power x into f of x plus f dash of x dot dx is equal to e power x dot f of x plus c. So for this, we have to know the integration and differentiation formulas well. So the prerequisite for this is we have to know the formulas pretty much well. Okay. We all know what is tan inverse of x differentiation, 1 by 1 plus x square. So it is satisfying this formula. E power x into f of x plus f dash of x dot dx is equal to what? E power x f of x. So my f of x is tan inverse of x. And different tan inverse of x is what? 1 by 1 plus x square. So those are unable to get it. My f of x is what? Tan inverse of x. F dash of x in the sense differentiation tan inverse of x is 1 by 1 plus x square. That's it. So I can apply this same formula. So the answer is e power x into tan inverse of x. That's all. We can see the answer here. E power x into tan inverse of x. So when to apply this formula? So in the problem, if you see e power x, then the simple formula we have to apply. Now let's take this problem. It is integral of x square plus 1 by x plus 1 the whole square. Integral of x square plus 1 by x plus 1 the whole square dot dx. And I think e power x is also there, I think. So let me check, confirm by taking that. Yeah, e power x is there in the numerator. So once we find e power x, immediately our mind should think to what? It should be of the form e power x into f of x. Correct? And by seeing x plus 1 the whole square, we all know one thing. What is u by v? U by v rule we all know. That is by v square. That is x plus 1 the whole square. If I'm taking v as x plus 1, correct? U by v square. U by v square. So this is u by v rule is what? U dash v minus uv dash by v square. So if I'm applying here, v is what? X plus 1. And let me take u as 1. So I'm just teaching you the approaches to do the problem. So I'm not actually solving the problem, but I'm telling you how to think. Okay, the main idea here is not to solve the or get the answer. That is not the way, is how to approach a problem. The way is how to think. So for me, two things are important: approaching a problem and think, or the thought process. So 1 by x plus 1. If I want to differentiate, let me take differentiation of 1 by x plus 1. So u by v rule I'm doing. So x plus 1 the whole square. Correct? U dash, u is my 1. So obviously it is 0 here. So 0 and x plus 1 is 0. minus uv dash. What is it? What is the answer here? This one I will keep it constant, and differentiation of x is what? Again 1, and 1 is 0. So minus 1 by x plus 1 the whole square. Minus 1 by x plus 1 the whole square. Or else, what is differentiation of 1 by x? Minus 1 by x square. Minus 1 by x square. Correct? Minus 1 by x square. So same thing I'm doing in getting rid of minus 1 by x plus 1 the whole square. But the problem with this problem is what? Basically, this is having something called x square plus 1. 1 by x plus 1 the whole square is fine. But this is having something called x square plus 1. So how do I get to this? X square plus 1. 1 is already I got minus 1 by x plus 1 the whole square. That is if I differentiate this. But in the question, is there minus 1 here? No. In the question, there is no minus 1. So what I will do, I will add 1 and I will subtract 1. So with this question, I will subtract 1 and I will add 1. Okay, so see, if I want, I can tell this thing in a structured way, which is very easy for you to understand. But I want everyone to explore the various way of solving the problem. Why did I subtract plus 1 and minus 1? I'm writing it down so that everyone will understand this. Plus 1 and minus 1. Because I know 1 by x plus 1 differentiation, d by dx of 1 by x plus 1 is what? Minus 1 by x plus 1 the whole square. Minus 1 is not present in the question. So you'll have so many doubts running in the mind. Kindly just listen. Okay, minus 1 is not present in the question. So that is the reason I am adding plus 1 and minus 1. Okay. Now, what I will do is, I will rearrange. I'll rearrange what? X square minus 1 as one term. X square minus 1 as one term. Plus 1 plus 1 is what? 2. This is another term. So x square minus 1 by x plus 1 the whole square plus 2 by x plus 1 the whole square. And everything is with what? Into e power x. Into e power x. What is x square minus 1? X square minus 1 is x plus 1 into x minus 1. Correct? So I will get on the numerator what? X minus 1 by x plus 1 the whole square. If it is not clear, I'll just write it down one more time. Or if you want the step, I will write with the step. X square minus 1 is what? X plus 1 into x minus 1 by x plus 1 the whole square. Correct? Plus 2 by x plus 1 the whole square. 2 by x plus 1 the whole square into e power x. Into what? E power x. Now what I'm going to do is I'm going to cancel that x plus 1 and here one x plus 1. So what term I will be getting? I'll be getting what? X minus 1 by x plus 1, correct? Plus 2 by x plus 1 the whole square into e power x. Now if I differentiate x minus 1 by x plus 1, now if I differentiate d by dx of x minus 1 by x plus 1, uv rule, so by x plus 1 the whole square, correct? uv dash or u dash v is what? Differentiation of this term, that is 1. This is my x plus 1, correct? Minus, which is constant now, uv dash minus x minus 1. So yeah, minus x minus 1, and x plus 1 difference, x minus 1 differentiation is what? So this is basically u dash v minus uv dash by v square. So this is my u and this is my v. So by v square is fine. U dash v, I think everyone understood, correct? Minus uv dash. So u is constant. So x minus 1 is constant. V dash, difference of x is 1 and difference is 0. So I'm not going to write that thing. So x and x will get cancelled. 1, this is minus minus plus. So 1 plus 1, 2. So I'm getting 2 by x plus 1 the whole square. So in the sense, if I see this question, x minus 1 by x plus 1 differentiation is what? 2 by x plus 1 the whole square into e power x. Correct? So this is my f of x. This is my f dash of x. So the answer is what? E power x into f of x. So this into e power x. Okay. See, let me see the textbook. See, you can see the textbook. They have done minus 1, plus 1, and plus 1. But why did we do that? I can also simply say add plus 1 and subtract the thing, same thing. Correct? I can also say the same way. It's very easy. But for me, while explaining this question, I have to tell you why we are doing this. You got the point. So I started from what? Scratch. What is difference of 1 by x minus 1 by x square? What is difference of 1 by x plus 1 minus 1 by x plus 1 the whole square? First thing. So in the denominator, there is x plus 1 the whole square is there. Minus 1 by x plus 1 the whole square. I don't have minus 1 in the question itself. So that's the reason I subtracted minus 1. Let me show you here with the spotlight. I subtracted minus 1. Then I added plus 1. Then what did I do? I grouped the two things. X square minus 1. Correct? And this is 2. Then I simplified. Correct? What is a square minus b square? A plus b into a minus b. Then I clearly know without doing itself that the right hand side, this should be what? The differentiation of the left hand side. So the answer is e power x into f of x. So this is the thought process which I want to share here. Is it clear for everyone? Yeah. So let me go with the main topic in this. So I'm sure that everyone knows the basics of the limit problem. That I'm not going to discuss. Upper limit minus lower limit thing. But something which I have to discuss is, let me take one question to tell you. Yeah. So I want to take this particular question. So in entrance, they can ask this type of question. If I just do upper limit minus lower limit for a modulus question, okay, if I just put if I integrate this separately and if I integrate this separately, and if I just do upper limit minus lower limit, we will get wrong answer for the modulus question. First one, for the modulus type questions. Okay, we have to split the limits. Suppose in the limit -1 to 2 is given and it is modulus. So how do you split it? -1 to 0 and the modulus whatever is there here plus 0 to 1 plus 1 to 2. Only if you do like this splitting, then you will get the correct answer. If you directly do with the modulus, if I integrate, we won't get it. The correct answer. Clear to everyone? So we won't be getting the correct answer for the modulus type questions in this. So I'm sure that everyone knows how to do the integration of this. And then coming to the properties. So there are totally 7 properties. Yeah. So why I want to discuss with integration with limits is, normally if I get an integration question, in entrance thing, that is without limits, okay, without limits, just differentiate the answer. By seeing itself, you'll get it. We have to be good at differentiation. Just differentiate the options and use the process of elimination. That's it. But with limits, if the question is coming with limits, then we may have to apply the properties. But one more important thing what I will tell you is, integration with limits for the entrance, only question from this particular NCERT textbook only will be asked. Either from the example, same question sometimes they will give, or from the exercises. Any of this will come for the entrance for sure. So even if you by heart the answer, that is nothing wrong. You got the point. Because end of the day, your rank will count. No one will ask whether you are by hearted or you know the concept. I'm telling you to by heart in the sense, suppose you are solving all of these problems, we'll know the answer, right? If you're repeating this problems, if you're repeatedly solving all the problems, the answer will be always there in our head. So just by seeing the answer, we can just tick it and just go to the next thing. So we can save time. And also in my sessions, I have told which all exercises are important in the integration. Except vectors and 3D, from all the chapters, questions will be from the textbook only, mostly. Or they can just change some number, that's it. Same questions, will just change the number. And now coming to the properties, which all properties you have to study. So let me take the properties first. So property number 2, that's what we just now used it, correct? Integral of a to b f of x dx is nothing but what I'm splitting it. That is just now what we did. Property number 3, that also sometimes we'll use it. Okay. Property number 4, yes, that also we will use it. And property number 7. So 2, 3, 4, and 7. 7, I'm sure that you're unable to see it. So 7 is nothing but it will be applied only for an even function, in the sense x square, x power 4, sine square x, correct? if it is of the limits integral -1 to 1, integral of -1 to 1 x square. So I can write as what 2 integral 0 to 1. I'm not writing dx and all now because it's an entrance preparation. So no one is going to check our worksheet. We have to save time. So I'm just telling, since it's an even function, I just did what 2 integral 0 to 1. So these are few properties which you have to remember. Okay. And property number 4, where do we use this? Integral 0 to a. We use in 0 to pi, and when the function is what? Sin x or cos x. Sin x or cos x. So we'll write it as what? Sin pi minus x, cos pi minus x. Or let's take 0 to pi by 2, sin x. I'm just giving you sin x integration, we all know, but I'm just telling you, okay, where do we use it? Sin pi by 2 minus x, that is cos x. Sin pi minus x. What is sin pi minus x? Sin x itself. Is sin pi minus x sin x itself or some other thing? What is the value of sin pi minus x? Sin of pi minus x. What is the value of that? My question is, I'll type in the chat and give to you. Sin pi minus x, what is the value? Okay, I'm getting two answers I got from Prithvi and Rohan. Others? Others, please tell me the thing. What is sin pi minus x? Only two answers I got. And guys, we have to be very competitive now. Okay. Only those who say the answers, they only will go to the next level. Okay, I'm getting x minus x cos 90 minus cos x. Answer is right or wrong, we are least bothered here. I'm getting minus x, then cos x, minus cos x, then cos 90 something. See, the question is sine of pi 180 minus x. That is a question. If it is sine 90 minus x, what is it? Complementary angles, cos x. 180 minus x in the sense which quadrant it will be? It will be in second quadrant where sine is positive. All silver teacups. Correct? I'm again getting an answer here. Minus cos x. No. Sine 180 minus x is just sine x only. Cos 180 minus x is what? It will be somewhere here. That is, cos is negative in that quadrant, minus cos x. So we have to again revisit our trigonometry class 11th. Okay. So draw the quadrant, you will automatically get the answer. This is simple stuff. Now let me come back to the questions here. So I highly appreciate all of the guys who has given me the answer. Okay, whether it's right or wrong, that is secondary. Now see this question. Integral minus a to a sine square x dx. So sine square is what? Even function. So I'll write 2 integral 0 to pi by 4 sine square x. Now what is my sine square x? We know what 1 minus Cos 2x is what? What is 1 minus cos 2x? 2 sine square x. 2 sine square x. It is not 2x, it is 2 sine square x. So what is my sine square x? Yes. Sine square x is 1 minus cos 2x by 2. Correct? Sine square x is 1 minus cos 2x by 2. We all know what is integration of 1 by 2. We all know what is integration of cos 2x. What is cos 2x integration? Sine 2x by 2. Then you have to apply the limits. Yes. We don't know how to integrate sine square x, but we know this thing. That's all. And I'm not going to do the integration now. Okay, so I hope everyone knows what to do with the limits. Then you should try and let me know. Once the class is over, I'll be giving you that work. Now coming to the 0 to pi. I told you whenever 0 to pi is coming, we have to substitute what? X as pi minus x. X as what? Pi minus x. Integral 0 to a. F of x is equal to what? Integral 0 to a. F of a minus x. One more property. So what will happen here? Pi minus x and sine pi minus x is coming. What is sine pi minus x? Sine x. What is this step from this to this? I am multiplying pi with what? This pi, let me take it outside. This is the normal pi. Okay. Yeah. So I am multiplying sine x with this pi. So pi sine x, and that pi I have taken outside. Yes. Minus x sine x minus x sine x by 1 plus cos square x. That is nothing but the question I. So this I will go to this side. I plus I 2i. I plus I 2i. Correct? 2i is equal to this pi. Then now you have to integrate what? This thing. So this is a very simple thing. Almost we have done this in integration by substitution. So if I put cos x is equal to t, definition of cos x is what? Minus sin x dot dx is equal to dt. So numerator can be replaced with dt by 1 plus t square, dt by minus dt by 1 plus t square. And the most important thing in the limits is, I'll write it down here. In limits, this is very important. In limits, whenever we are doing substitution, that is integration by substitution, we have to change the upper and lower limits, upper and lower limits respectively. Correct? In the sense, if I put cos x is equal to t here, if I put cos x is equal to t here, now what is my x value? 0. When x is equal to 0, what is t value? Cos 0 is 1. When x is equal to p, what is the t value? So when x is equal to pi, sorry, not t, x is equal to pi, what is the t value? Cos pi, what is the value of cos pi? Cos pi is minus 1. Cos pi is minus 1. So it varies with what? 1 to minus 1, it will vary. Yes. Sin pi is 0. Okay. Yeah. Sin pi is 0. So it varies from 1 to minus 1 respectively. Correct. So that is the most important learning in this. Now let me come down. Yeah. What is integral of 1 by 1 plus t square tan inverse of t? So again, we have to know the integration of 1 by 1 plus t square, or tan inverse of differentiation is what? Tan inverse of x differentiation is 1 by 1 plus x square. So integral of 1 by 1 plus t square is what? Tan inverse of t. So this is one more thing we have to know. Correct? And here it is minus. And if I change the limits, upper limit and lower limit, I can remove the minus. If I multiply, if I put the minus in the limits, I can change the limits. This is one more property. And then we have to apply the limits, and then we should know upper limit minus lower limit. Tan inverse of 1. What value of tan? It will give me 1 tan 45. That is nothing but pi by 4. Tan 0 is 0 anyway. So that's it. Now let's see this question. Sine power 5x into cos power 4x dot dx. Integral minus a to a. Sine power 5 is what function? 5 and this is 4. This is an odd function. So if it is an odd function, the answer is 0. Integral minus a to a, or integral minus 1 to 1. If it is odd number is coming, odd. If it is not x square or sine square x or sine power 4x. If it is sine power 5x is an odd function. Odd function, directly I can write the answer 0. So this is with the integration with the limits. Definite integral using properties. So as I already told, we have to know the which properties well. Again, one more time, I'll just show to you. 2, 3, 4, and 7. 2, 3, 4, and 7.